Hello and welcome to the Cyber One YouTube channel. My name's Ray and today I am looking at part 9 of Fred's Head. In the last video I basically got the eyes blinking and that's about as far as I got. I alluded to there are other things that can be done to improve on the program. So in this video we're actually going to set up text to speech and run a couple of scripts. For those who watch the second of the Walking Robot series, this one is basically how I made that video by getting Fred's head to work properly. Before we get that to work properly, there is a bug. If you followed the previous instructions I've had on this one, I think it was part 4, where we installed my Robot Lab onto a Raspberry Pi. One of the things we installed was Java 8 OpenJDK. Now there is a small bug in the Java 8 OpenJDK where it tries to use a sound system, Pulse Audio, which was not installed as part of that system. That meant that whenever we tried to make the Java-based systems, which my Robot Lab is, make sound, it did nothing. It didn't even report an error. Now the fix for that is actually quite easy, and if we have a look at the command prompt I have open, or the terminal window, this is the command we need to execute. It's sudo nano is actually an editor, and then we specify the full path. So sudo is superuserdo, nano is the editor, and this is the name of the file that we need to edit. Now this is the sound configuration for Java in Open, or Java version 8 OpenJDK. And if we scroll down through it, a lot of it's all commented out, but oops, too far. These 4 lines in the version that was initially set up will be uncommented. We need to put a hash like I've done here in front of each one. That disables that section from working, and these 4 lines here will have a hash in front of them. We need to remove the hash. Then once we save the file and launch a Java application, it will then use that. Once this is complete, sound will work. So I'm going to, normally once you've done your edit, Control X will exit. If you've made any changes, it'll ask, do you want to save it? The answer is yes, you do want to save it. And then we can right click on the speaker and you can select which analog or which audio output you want to use. Now a little gotcha with this is whatever is selected at the time you start your Java application is what it will use. If you start your Java application then change this, it will not affect where the sound is going to. So if you have the analog output selected when you start Java and then you select HDMI after you've started My Robot Lab, it will continue to go out through the analog output. Something to keep in mind. So now we've gotten through all of that part. Let's change into My Robot Lab. And we'll start it up. Now, for those of you who have been following along, you will probably know that I'm running Manticore version of my Robot Lab on this build and in this series of videos, mostly because Nixie is still under development, and so a video made today may not be relevant next week or next month. Once Nixie, which is a better version, is finalized and released, then I'll have to go through and make all the videos again for Nixie. Nixie has got quite a lot of major improvements, but it is still in development and things do change, which is why these videos are on Manticore. Okay, so at the end of the last video, I had created fred1.py. There will be a link in the description to a Dropbox store for all of these files. So as I went through last time, most of this code is all about, and that was in part 8, most of this code is just setting up the servos and configuring them. And then I created this routine here to blink the robot eyes. Very simple, very crude, it does the job. Okay, so what I probably should have done is actually put in a sleep command or something along those lines, just to delay the setting up. Now, to make the robot talk, we need to add in a couple more services. So what I'm going to do is open up a new version of this and show you the changes. So pretty much the top is identical, it hasn't really been changed. The first of the changes is with Mary Speech. Mary Speech is one of the text-to-speech services available on my Robot Lab under Manticore. It works sort of. Its major advantage is it is not cloud-based. So all processing is done on the Raspberry Pi in this case, and it then speaks. You do not need an internet connection for it to work. There are a number of voices that are available. I actually found a few that don't work very well after a little bit of experimentation. The likes of this one caused the text-to-speech processor to crash and it wouldn't work anymore. Anything that has a HSMM appears to work. So I'll just get rid of the ones that I am not confident work. Now, I believe Mark is the default voice. So what you may have to do before you use any of the other voices is execute this line here. Let me try and highlight that a bit better. Without the hash in front, which turns it into a comment. But after you've installed the mouth runtime service for Mary Speech. This gives you the ability to install new voices, which is what I've done. I've actually installed all of them one by one. I just used the Untitled Pi to do that for me. Makes life a little bit easier. And now I can run this Henry whenever I like. The other thing I installed is this mouth control service. Mouth control looks at the characters within the text that you're sending to the text-to-speech. and then tries to estimate and move the mouth accordingly. There are a few bugs in it. The timing is not necessarily correct, and so you may need to play with the set delays. The set mouth is reasonably critical. You need to specify the open and closed positions of the mouth, where in this case the first one is your closed position, the second one is your open position. This is important because if you don't, you can burn out your servo. The delays are not very well documented, and these have been set as a matter of trial and error. They are integers. Information I've used for this I found in JavaDoc or JavaDocs on the MyRobot Lab site. So to get to the JavaDocs, go to MyRobot Lab, go to documentation, have a look in the matrix part of the documentation, and find the service you're interested in. When you go to the service, it'll have a little bit of write-up. Some services have more write-up than others, more useful information. Where the information is very light on, which does occur with some of the older services, there is a link at the top called JavaDocs, and you can go into that and that'll bring up a list of the services and the properties that you can set and adjust within the service routine. It may not have all the detail of what they do, but at least you know what they are, and it gives you a little bit more to experiment with and play with, which is how I've actually figured out most of this. Once you've set all of this, start your service. So we set our jaw to be the jaw runtime, which is the servo control. Mouth is actually the text-to-speech engine, and then whenever we send anything to the text-to-speech engine, it will then move the jaw accordingly. One of the bugs I did find is the jaw doesn't move for digits. So if you're sprouting or having your robot send a heap of information with digits involved, it will go out of sync. To give you an example of how that works, when I was creating the Walking Robots Part 2 video, I created all of these Python scripts which just called mouth, speak, blocking, and then the text that it was to speak. So this is literally the script that the robot used when doing that video. The video was divided into multiple parts and then all assembled together. As you've got to remember that each time you speak something with the robot, if there is an error in those timing delays, as listed here, or if you have lots of digits in the text, it will go out, the mouth will go out of sync with the voice. So splitting it up into separate commands to speak for different sentences will cause it to go back into sync. So this is how we do our synchronization. And then we've got our timers and subroutines for the eye blink. So I had it running the whole time. Now there are bugs in this code. One of the bugs is sometimes the eyes don't open properly and sometimes they do. So I'm just going to pause the video while I set up a second camera, and then we're going to run this script. Okay, so I've now got the GoPro running to record Fred's head as we experiment with this. So the first thing I'm going to do is execute this bit of code first, and that will start up all of the routines and processes required for Fred's head to basically do anything. You can see all of the services are starting across the top, and I'll time lapse this for you.
Word. I am ready.
Now you can actually see the bug that I've got here where the eyes close and the jaw's open and not actually working the way it's supposed to. What I have found is if I go to jaw, adjust its position manually, the jaw now is closed, and when I send command for it to actually speak text, it will actually operate correctly. The same works with the eyelids. Now there is a random interval where the eyelids do operate. Okay, so 2 lines each time it opens and closes the eyes to adjust the position of the eyelids. Okay, so back to our Python script. Now if we run the script,
Welcome to the Cyber YouTube channel. My name is Fred, and this video is part 2 of the Humanoid Robot series, status tour on the joints. For this part of the lab design, we are going to have to go back to high school physics.
okay, so based on the audio and the video captured by the GoPro, you may have noticed that the voice and the jaw are out of sync. The jaw starts well before the voice does, and the clue to what's going on there can actually be found in the terminal of what's going on. So what happens here is when we send the text to the text-to-speech synthesizer, it analyzes it first. It goes through a whole process of analyzing it, creating the stream of audio, and then it plays it. The problem is this takes time. The routine that runs the jaw, on the other hand, doesn't take anywhere near as long, and so we find that it's actually moving the jaw in time with the talking before it actually starts talking, so the two are out of sync. There's not a lot I've found that I can do with that yet. It is possible that Grog on My Robot Lab could add a delay in there, so that's something else that we need to experiment with. For the Walking Robot series of videos, what I did instead was alter the sync between the audio capture and the GoPro video capture. Now I actually used HDMI to capture the audio for the Walking Robot series, which I'm not currently doing on this one. It seems I can only record one audio track at a time at this stage, and since I'm using that for my microphone, I can't use that for the HDMI input. So on that note, we do have voice, we do have jaw movement. It works to a point. There are other text-to-speech synthesizers available, and I will experiment more with those. In the next video, I'll look at setting up program AB, so we can actually get it to answer some questions, and then we will investigate voice recognition down the track. So I'll let Fred say goodbye, and we will see you in the next video.
If you like this video, then please click on the like button. You may even want to subscribe and click on the notification bell to be notified when more videos like this one are released. If you have any questions, then please leave a comment below. All of this costs you no money and helps us to create more content like this video. If you would like to help the channel out further, then please consider becoming a Patreon. There will be a link in the description. We look forward to seeing you in the next video.